Hello, hi Ravindra. Am I audible? Hi everyone. How are you all doing? I hope everyone is being doing great and being safe at their places. So we have been reading about the machine learning, the statistics too. So today we're gonna perform 2 to 3 more of the examples in the Jupyter notebook. We are showing you how to implement the programs and the concepts in the Jupyter notebook. So moving forward to that, let's shift to that and share my screen. So before going to that, let's know more some little concepts of probability too. As already we discussed in the last classes about the probability, the introduction to probability, but still in the classification of your probability, we have left with. So considering that, we will be shifting towards the what is actually the probability, the difference between probability is, and why we use the probability in most of our concepts. Nowadays, there are a lot of concepts we are being using the probability just because of to make it easy and make it suitable to. But the problem is like how efficient you are being using. Okay, nothing else to that, like how you have been using or how not. But uh, there are some of the concepts where these of the probability are being implemented about. So just for the simple introduction about the probability. So probability is something like something is to be happen. Okay, the chance to get happen. Whenever we used to ensure or like are being unsure to about the outcome of the event, we can talk about the probabilities of certain outcomes and that individually to that, like however like analyzing anything we can analyze of the event governed by any of your probability or being directed by any of your probability is known as the strategy, which we already have been read about. So what is the probability in the defined name? So probability is the branch of your mathematics, like where we used to concerned about the numerical description and how the event will be occur. And there are some proportions where we have to give the Sorry guys, I guess my network issue was there. Yeah. So I was just telling to you. So I was just telling to you regarding how we implement the Jupyter notebook and what is the benefit of Jupyter notebook and why we approach Jupyter notebook for considering an ML programs or any of your NLPs, and there are certain more about the Jupyter notebook. So now how why we operate on Jupyter notebook, not on any other thing. What is the benefit about the Jupyter? First of all, the Jupyter notebook, that is open document format, that is just based upon your JSON. So these all contain your records of any of your code in that, or any of your the session part is there. Okay, so Jupyter notebook is an just a project in the community where we have a goal about develop open source software and any of your open standards and any of that, just because of we're not considering these projects as an primarily, but yeah, it's in an important. So there is an uh, it is in a spun off of your 2014 feature of the IPython. It has been given by the Fernando Perez, and the main purpose of the Python notebook was and is to just support interactive data science and even the scientific termings and across each and every programming language. It is not just of when you are been performing on Python and Java, and it is considering all the file extensions and that. So, okay, and the file extensions where we have it in the PyNab. Okay, and it is just a notebook documentation about the Jupyter notebook. Okay, now moving forward, why we opted the Jupyter notebook and how the Jupyter notebook has been given in the further generations, as an exactly the part would be. So to open the Jupyter, either you can open from your Chrome to, but it would not be as suitable because the standard variation might be somewhat different in this. So to open this, first of all, command prompt. If your command prompt attempts to give you permission about the Jupyter notebook, you can avail that. But I don't think so. It would be either you can go to and download the Anaconda prompt. Okay, open it. Just let it be read till the time. To enter, let's enter it. Okay. So to that we have to write it Jupyter. It will already redirect you to the main browser. It will take time to reload. Yeah. So it will automatically reload, being pushed to you as an to the Chrome, and wherever these stylish part has been there or any of that, it would be a basic criteria to open your Jupyter notebook. Either you can open or download it as a local tool, or you can download it as a machine too, because in your Linux or in your Kali Linux or in your Linux, Ubuntu, everything would be as an pre-install. Nothing you have to install it further to. Okay, so if you have been working in your Windows, either you can install for the Windows, but if you not don't want to as an packages part, you can go through the Anaconda prompt, and then after that you can apply to the Jupyter notebook. Okay, now it has been directed us to the Jupyter. Over here you can see that we have all the files, whatever there are as in searches in your that the system. or any of that. In the running section, there is no terminal running. The cluster you can create it. Okay. Now here you can go to the new, and after that either you want to consider as in Python 3 text file folder or terminal, any of that you can click up. Now we need as in the Python 3 where we're gonna perform it, and then so it's one of the example. Either there are two examples, but still what the example is all about. If we open that. So the example for Jupyter Notebook as well, whatever we're gonna perform it. So here's one very common example about the CLT and the exponential distributed population both. So this example is basically given as a random variable, whereas in the statics or the sample means, and after that you have to just show about the different values in that. Okay, so it depends upon why your value should be concentrated or not. Okay, it doesn't matter as if your ex in whatever the x functions are being given or not. So this example is about the exponentially distributed population. In this, we basically gonna deal with a population which is highly exponentially distributed. Okay, I'm not using the exponential distributed, I'm using highly exponential because the peak mark you can see that it has a highly exponential distribution point. Even to the starting to the first of all, just as in straightforward, then it is going to bend upon as in curve part. Okay, so in every distribution it has been continuous, because you know in the exponential distribution it has been continuous about the distribution. Wherever we're going to use the model, or we have to expect that all the needs or the variation and everything before the occurrence of that event. Okay, if the occurrence of that event is not there, so it won't be happening as a prejudgmental. So suppose, wait, so suppose this is the and actually this is your graph about this question, whatever I spoke, and we know that the parameters are being the lambda and such as like both the parameters and the rate parameters as in lambda. Lambda is your rate parameter, and after that, if we give that as in 1 by lambda, so it would be your the both the mean and your standard deviation with the proportions. So this is the graph which is being representing the exponential distributed and population. And here is a function about why this function has been given as in problematic addition. Okay, now when we know that ex and uh, the population is so far as a normal part only, so which means like if you have then the mean and the standard deviation, it would not be configured out as in much. So according to this only, we have to perform one program to consider this only. So let's move towards a Jupyter notebook. So remember, if you want to give each and every import as in first cell only, or either you want to divide that cells accordingly, you can do it, because it is not mandatory to get each and every cell recorded, because it is either independent or dependent variable recognizing about the sets of set of your the cell dependency. So let's perform one program to see that the distribution of our population is far more normal too. And in any case, like whenever we used to have a lambda function or any of that, we will calculate. In this, we will calculate the mean and the standard deviation of the population. So first of all, let's import the libraries first. Over to import warning. So moving forward to the next cell about the import. Okay, now in the next cell is import warning dot filters. So you have to keep check about you have to keep check about the each of your for running each in cell you have to enter shift plus enter, or you can simply go to the run part also. Okay, this is not mandatory. Okay, you have to just give up on the shift bar only. No, you can enter anywhere and you can check like whenever you press the shift dot enter, and this line will be considering as in plus part, and will not give if it give any error, like there's some mistake in your importing on writing any of the syntax or variables, any of that. Okay, but when I enter that shift plus one, it is not giving me any error and the line has been passed to. So for the warnings, we have to write warning dot filter warnings ignore. Okay, now for the ignorance, again we go for a plus one. Okay, in this also part we have to enter shift plus one. Now we will be import pandas as PD, or you can go for the nampas also as in same. Again enter shift plus that part. Oh, sorry, I didn't write as a pandas as PD. Okay, again enter shift plus enter. Okay, now similarly I'll import numpy 2 in shift plus enter. So for the inline nations of your each and every program, importing matplotlib, matplot. See, you can, I'm being separating these all the files and everything. You can write as same also as in one set. Okay, now I'm being writing as an import matplotlib dot pyplot as pl. Now again enter plus enter. Now for the initialization of your matplotlib in the separate cell of the window, you will be adding matplotlib inline. Enter, or either we will be importing our uh, Cbon also, but there is no need about the Cbon to be imported as in library, because either it will give us an error about the synchronization. Yeah, you can see that it will give us the error about the synchronization. Either we can remove it both and given this as an another line. Okay. SNS. Okay. Now again it will be giving us the error. Leave it. This there is no use about this the C vulnerable here. Now comes about the parameters of the rate, and which is being used for the exponentially distributed population. About how we write that the parameter rate. The rate we will be declaring. So for the rate, yeah, it has 0. Anything you can give it. Okay. Again for the population mean, so I'll write it for you in a hashtag so that you can remember what is for this. This is for the rate parameter. And again in the below we will calculate the population mean. We'll be calculating as a population mean. The population mean, we will be writing as a formula of y mu is equals to 1 by rate. Okay, enter it again, and after that, let's find out. Wait, what is the wrong in that? Okay, so this cell would not be just commented. Okay, no worries about the deleting the cell and all. So for the population standard deviation, but the cell is for the standard deviation of the population. Here we will be writing about the concepts of what your square roots are being meant to. Okay, so now it depends upon the how your square roots are being given. For here, your square roots will be given as the SD. We have to declare it first of all. Okay, and nobody knows what is the SD or what. To declare it as a pre-requirement. Okay, now it is being given as a square root. I in the previous part also I just gave you whatever the theorems are being there or whatever the immunizations are being there, just read out, okay, in that and remember off, because it is difficult but you don't have to forget it. Okay, again I'll be entering this and running the cell, and you can see that the cell has been entered through. So now comes the main output about the printing. So over here, if I want the population mean, okay, I need the population mean. Now, if I run this, so you can see the population mean is 4.0. So now how the 4.0 has been given? We have given the rate as in 0.25 the value, okay, and then the 0.25 value has been entered to this formula as in standard deviation of your population. NP is a square root of what? Okay, now from MU, it has been calculated from here. After that, the standard deviation has been given. If similarly, if I change the value as in 5, and again you have to run the cell as in shift plus enter. So shift plus enter. So the value would be 0.2. More the number of the rate parameter, the lesser the value of your population mean will be. Okay, so it is inversely proportional to each other. So if I write a 10, now check what is the value of. So it would be then 0. It has been decreasing by 0.1 when we increase the rate by the 5 number, any of that. Similarly to that, if we write only n only 0.25, again then we run it. So it would be the 4. More the number of rate, less would be the population mean. Less would be the rate, the more with the population mean would be. Okay. Similarly, if I have to the print, wait, I'll write copy here. Similarly, if I have to print the population standard deviation, over here, if I, because over here that is SD, okay, and for the standard deviation we know we use as SD as in short form. Again, if I run this, and it will again come as in 4. So how it occurred and what it is, we see like how the sampling distribution looks in your population. Okay. Similarly, the case, these are the two cases. If we are representing the NP or any of that, so it will not be given as the similarly part of individual. Okay, it depends upon what your value is, and we can see that the standard deviation population is far more than normal part. Okay, if I again change value as in 0.75, okay, and after that again I'll run the cell by shift plus enter. Okay, so it would be 1.13 and it would be 1.13. Change the variable as in rate square, because similarly if you have to inverse part of the rate, inverse part of your standard deviation as in particular terms, so you have to change that part. If you similarly go to upper cell, run from there, enter, 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 and that. So now you can see that your the population mean is 1 and your population standard mean is 1.3. How it comes? So mu is 1 by rate. What is rate? 0.75. 0.75. So it is being equally deducted. And what is SD? Is NP square root of 1 square rate of square. Okay, so that how it came, nothing else. So from the above, we will be calculating now. So you know that each and every cell has been popularized and filled out. So from import warning, I'll be entering as a shift plus enter, shift plus enter, shift plus enter, shift plus enter, 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 enter. Then again shift plus enter, enter. So here is the finalized output about the population mean and population standard deviation. Okay, nothing else is there. Everything is being sorted out. So now comes about the very. I hope it has been clear to you, everyone. Right? Shall we start further? Okay, then let's move forward. Till now, have a look about this program. I hope everything has been clear to you. Have a look on this program. So moving forward to that, about the hypothesis testing, we will perform a simple Z test. Okay, and in the formulation of your simple Z test, we will be knowing about how your program has been given as in population in the instance. Okay, so as we already know that the what is statistics hypothesis testing, so it allows us to as already know what is hypothesis and everything. For the just a clearance about the revision of your concept, so I'll tell you again about the hypothesis testing. So it allows us to make the decision in the presence of your incomplete data. Okay, because nothing data has been completed, either it has been processed, it has been refined, and the final output the processing has been done. So nothing has been complete in the data formation. So moving forward to that, we know that if each and every decision are being uncertain, and statistically we know we have to develop the methods to evaluate the risk also, because there is nothing to be getting the risk about. So the Z test, what it shows us, show us to how to briefly explain the underlines, okay, and the overfitting to about the frequenciest part. So it is widely used about the getting the things part. So we know many frequency-based method are being given for the hypothesis testing, which are probably being noting down as an the consideration steps. Okay, what are the steps we you should take about the hypothesis testing? Let's write it. Very first test. The very first test is, first of all we have to conduct the hypothesis. We have to perform the hypothesis, and after that, oh sorry, it's not working. Wait. The very first method about the hypothesis testing is we have to first of all create or we have to write first of all the hypothesis. Okay, and after that we have to create and consider as an null hypothesis. I'm just writing hypo. Okay, whenever it has been proved with a certain degree or any of that, we will compute a test. Second part is the computing of the test. Compute test. Okay, and the test, what is form of the test is and in their statistics. Another one is we have to compute the values. So third point. Okay. I hope it is now shared on YouTube, the notepad. Is it? Okay, acknowledge. Is it visible now on the YouTube? Okay, thank you. Okay, so I was just writing about how do we test about the hypothesis methods for many of your frequencies testing and definitely because these are the steps I'm being writing about. First of all, we have to write down the hypothesis notably because to represent the null hypothesis, which is just an opposite to the hypothesis to prove in a certain degree or the resemblance to that. Second point was to compute the test, to compute the test statistics, which is a mathematical formula depending on any type of your test are being performing. But you have to use the models in that. Okay. Third one was we have to use the computative values. Okay. Now, for what reason we have to use the computative values? It's computed values. Okay, for why we have to use it, we have to reject that hypothesis also, whatever it is being given at the whatever level is it there. Consequently, either we have to reject it or we have to accept it. Okay, the third was the fourth one was the we have to overfail that or we have to conclude or to accept it. Okay, just let me write. Accept or fail. Now, if I say you one of the program, let us perform one of the program. Let me. Okay, I'll perform here. So there is in one program about that the coin. Okay, we know then coin we have two faces that is head and tail. If we flip that coin, okay, suppose we flip that coin to. Please move away from this. Oh, sorry. If we write that value as in statistical part, I shared about the coin. If we flip it, we know we have a coin flipness of the two faces, that is heads and tails. But if we have flipped the coin, if we flip the coin, sorry, writing is not good. Still, if we flip the coin to the n times, how many times it is to the n times, and we will observe that it is h. We will observe that it has been h. And if we wanted to know about either the coin is being fair or not, If it is not fair, it is the null hypothesis. If it is being fair, it is being hypothesis in the statistical form. So, according to that, we have to get an example, particularly about the quite useful part. Okay. Here we will be using as a Bernoulli distribution also, that is BQ about the, the Bernoulli distribution. So, according to Bernoulli distribution, we know the unknown parameters are being there. And about the unknown parameters, if someone doesn't know about the Bernoulli distribution, let me explain in the Bernoulli theorem and the distribution about. So this is all just a part about the distribution taken according to the mathematician Jacob Bernoulli, and what he said about and what he did about. He just said about wherever the passing of your special case will be there in your Bernoulli theorem as a distribution for each and every single trial, it would be conducting either n or would be 1 as a true value for such an value in your parameters in a 2 point distribution. So which it means like it doesn't require to come only 1 or 0 in any case. Okay. Similarly to that, if I have tossed a coin and I have to forward the coin in the path. So suppose okay, let me just provide you one of the example over here about how your distribution are being done. So moving to in this part about your okay, it's visible now. Yeah. So I have to write a program about the coin which has been tossed, and I have to check that coin whether it is tossed accordingly or not. Now let us suppose the value of our n is being 100 flips. Okay, very first point I'll be writing value of n about the coining is equals to 100. And h is equals to 61 about the diagonalizations. And wherever we know about the q, if it comes about the q, so it would, the value of q would be 1 by. Now let's import, shift to the import variable. If I sorry, this cell or cut the cell. Okay, again I'll be importing SkyPy. Know about the stats as an in shift plus enter. Then again third import I'll be doing is import SkyPy dot special. So now about the computation part, now we will be computing the z square and the z score part, just defined by the formula x bar, which is have been there. So so there will be the formula about the x bar over there, which you don't have to remember, or in your either you can apply as an formula for the next section also whenever you wanted about the formula. First of all, let us define the variables. So we know n is equals to 100. Again, h we write h is 61. Then q is our half. So we will not write 1 by 2. We will be writing 0.5. Okay. Running this. And after that, about the formula declaration, we will be writing the variables. That x bar is equals to float divided by n. Okay, then again the x bar is equals to x bar to np dot sq square. Sqrt is the square, okay? Then n divided by q multiplication to, in the bracket, that is 1 minus, that we will run this. Okay, now if I say that okay, if I declared, okay, z 2.200, and if I enter, so the output would be 2.2. If I write again the formations of the z square as a computation part with the p values, so after write the p val is equals to 2. Okay, and we have to formation about the p. Outcome of the p value would be 0.27173. If I not write this also, if I again run this, so the outcome would be different about the declarations part, because the value of the variable of that would be not be given. So this is the value of p. This is the value of the p which is less, far more than less than 0.05, 0.5. So we will reject this as a null hypothesis and conclude it as the coin is probably not fair. Okay, and how it works about the coin tossing as in model sequence of your n, which is independent about the random variable. I hope this is also clear to you, this program. So about very often I'll tell you about, we read about the skeleton, and we did one program as in ppt part with the content. So there I'll be explaining about the skeleton, how, here is one example I'll give you about creating a series of indie arrays by using pandas upon that. Okay, if I undo that, I cannot. Okay, again I just show you how we make the series in the variable part. You have to import the libraries. I'm just writing this, all the import line by lines to just tell you about how we run these cells. Okay. The data is equals to np dot array, creating the array. I write again, it's there, then a is there. Let me do one thing, I'll copy paste this entirely. Oh, if I copy this, and after that I'll write it similar times. Okay, and drop that. Now I'll change it. I'm writing the alphabets A, U, G, R, then again A and V. Okay, just write it same. You don't have to just remember. Now, if I have to print my data in PD series, and then PD series, I have to write it the data part, and after that I'll print it. Oh, sorry. I guess it is indentation. I have to print it now. The data type is object, and here it comes about the data series, about how it is built in your NumPy SkyPy here as in part of your series. So an example, this is just an example to create a series from your array by using the pandas in that, nothing else. So that you can know about how your data representation has been done in your pandas. I hope you remember about the pandas, about NumPy tutorial, about about the entire representation of your data in the pandas are being done with the help of your tree structure, that is the series data frame, and the one more series data frame, I guess sequel. Yeah. So the pandas, you know that you have the 5 steps to do that. That is to load, to prepare, to manipulate, to model, to analyze. So there are the five states of doing the pandas and that. I hope it has been clear to you. Any doubt to anyone, just let me know. This is up to this about the programs. This is just a heavy program. You have to revise the concepts, whatever we learned in the previous tutorials. I hope it has been clear to you. Any doubt to anyone? Doubt to anyone? May I know? No doubt? Anyone have any doubt? Just let me know. Ask out. Okay, so we don't have any doubt. So yeah, then tomorrow we will be learning about the concepts of more the theorem part of your the machine learning. Okay, whatever we did as and programs. So, okay. Yep. Thank you everyone. Thank you for joining.